Imagine waking up tomorrow and discovering that Earth no longer exists. Not destroyed, not exploded, deleted. No debris, no crater, no radiation, just gone. At first, nothing in the universe would notice. The sun would continue shining exactly the same way it always has. The moon would suddenly lose its anchor and drift silently into space. And the billions of objects orbiting Earth, satellites, space stations, probes, would instantly find themselves traveling through empty space. But that's only the beginning. Because removing a planet from a solar system is not like removing a stone from a pile. It's more like removing a gear from a giant cosmic machine. Everything around it begins to shift. And the consequences would ripple across the entire solar system. The moon would be the first victim of this change. Right now, the moon is locked in a delicate gravitational dance with Earth. Our planet's gravity holds it in orbit like an invisible leash, but if Earth suddenly disappeared, that leash would snap instantly. The moon would continue moving in the same direction it was already traveling because of inertia, but without Earth's gravity pulling it back. Instead of orbiting Earth, the moon would begin orbiting the sun, but its path would not be stable. Over time, gravitational interactions with other planets could send the moon drifting deeper into the solar system or even ejected into interstellar space. And that's when the real chaos would begin. Because Earth isn't just another rock in orbit. It's a massive gravitational object weighing nearly 6 sextillion tons. Removing that mass would subtly change the balance of the solar system. At first, the changes would be tiny, but over millions of years, those tiny changes could reshape planetary orbits. Mercury might become slightly more unstable. Venus could experience shifts in gravitational interactions. Even Mars might slowly drift into a slightly different orbital path. And the asteroid belt would feel the change too, because the solar system is not static. It's a delicate gravitational web, and Earth is one of the threads holding that web together. But something even stranger would happen closer to home, the satellites. Right now, thousands of artificial satellites orbit Earth, forming a dense technological shell around our planet. GPS satellites, weather satellites, communication networks, and the International Space Station. If Earth vanished, every one of those objects would instantly become free-floating spacecraft. No gravity pulling them back, no atmosphere slowing them down. They would continue flying forward along their orbital paths, transforming into a massive cloud of artificial debris orbiting the sun. A silent technological graveyard drifting through space. But the biggest shock wouldn't happen in space, it would happen on the sun. Because Earth may be small compared to the sun, but its gravitational pull still has measurable effects. Astronomers thousands of light years away, observing our solar system, would suddenly notice something strange. The sun's tiny wobble would change. Because right now, the sun doesn't sit perfectly still. Every planet in the solar system pulls on it slightly, causing the sun to wobble as they orbit. Earth contributes to that motion. Remove Earth, and that wobble changes. Which means distant alien astronomers, if they exist, might suddenly realize something impossible has happened in our system. A planet simply vanished. And that raises a terrifying question. If a planet could be deleted, could something delete the entire solar system? And even more disturbing, could the universe itself be unstable? Because modern physics has revealed a possibility that sounds like science fiction. A cosmic glitch in reality itself.
a phenomenon scientists call vacuum decay. And if it ever happens, everything in the universe could disappear faster than the speed of light. But before we go that far, we need to understand something even stranger. What would happen to time itself if Earth vanished?
The moment Earth disappears, the Moon becomes a wandering world. Right now, the Moon is locked in orbit around Earth at a distance of about 384,000 kilometers. It moves at roughly 3,600 kilometers per hour, constantly falling toward Earth while missing it just enough to stay in orbit. This balance is called orbital mechanics. But if Earth suddenly vanished, that balance would break instantly. The Moon would not stop. It would not pause. It would simply continue moving in the exact direction it was already traveling at that moment. Instead of circling Earth, the Moon would begin orbiting the Sun. But its new path would be chaotic. Without Earth's gravity stabilizing its motion, the Moon's orbit would become vulnerable to the gravitational influence of other planets, especially Venus and Jupiter. Over millions of years, these interactions could gradually stretch and distort the Moon's orbit. One possibility is that the Moon would become a small independent planet orbiting the Sun. Another possibility is much darker. Jupiter, the giant gravitational king of the solar system, could eventually capture it. If that happened, the Moon might become just another icy satellite in Jupiter's enormous family of moons. But the Moon wouldn't be the only thing suddenly set free. Thousands of artificial satellites orbit Earth right now. Navigation satellites, military satellites, weather satellites, space telescopes, and of course, the International Space Station. Every one of them depends on Earth's gravity. Without it, they would instantly become objects traveling around the Sun. Imagine the entire infrastructure of human civilization, all the satellites we rely on, suddenly transforming into a cloud of metal drifting through space. GPS would vanish. Global communications would collapse. Weather prediction systems would disappear. But that would hardly matter, because if Earth itself were deleted, humanity would already be gone. Still, from a cosmic perspective, something fascinating would remain: our technological footprint. Thousands of satellites would continue orbiting the Sun for millions of years, a silent archaeological record of a civilization that once existed. If alien astronomers ever discovered them, they might see something strange: a swarm of artificial objects orbiting a star, but no planet nearby to explain them. A ghost civilization. But satellites are small. Their disappearance would barely affect the solar system. Earth itself, however, plays a much bigger role, because our planet contains enormous mass, and mass shapes gravity. Gravity shapes orbits, which means removing Earth changes the entire gravitational architecture of the solar system. At first, the changes would be tiny, but over millions of years, those small changes could become dramatic. Mars could drift slightly outward. Venus might shift inward. Asteroid trajectories could change. Some asteroids that would normally miss Earth might now collide with other planets. Others might escape the solar system entirely. The solar system would slowly reorganize itself. But here's something even stranger. Earth is not just influencing objects nearby. It's influencing the Sun itself. Right now, the Sun does not sit perfectly still. Every planet pulls on it slightly. These tiny gravitational tugs cause the Sun to wobble in space. Astronomers actually use this wobble to detect planets around distant stars. It's one of the main methods for discovering exoplanets. If Earth vanished, the Sun's wobble would change. The difference would be small, but measurable.
And somewhere far away in the galaxy, alien astronomers studying our star might suddenly notice something impossible. A planet in the solar system had vanished. No explosion, no debris, just gone. But could something actually remove a planet like that? Could a natural cosmic event truly delete Earth? At first, it sounds absurd, but the universe is capable of far stranger things than we usually imagine, because there is one cosmic object powerful enough to swallow an entire planet instantly: a black hole. And if a rogue black hole ever entered the solar system, Earth might not explode, it might not shatter, it might simply disappear.
At first, the solar system might seem unchanged. The sun would still shine, Mercury, Venus, Mars, and the outer planets would continue moving along their familiar paths around the sun. From a distance, everything would look almost normal. But gravity never forgets when something disappears. Earth may seem small compared to giants like Jupiter or Saturn, but it still carries enormous mass, about 5.97 sextillion kilograms. That mass contributes to the delicate gravitational balance that keeps the solar system stable. Remove Earth, and the entire system subtly shifts. At first, the changes would be tiny enough that no spacecraft or telescope would immediately notice them. But the solar system is a long-term machine. Over millions and billions of years, even the smallest gravitational changes can grow into massive differences. Mars would likely feel the effects first. Right now, Mars sits just outside Earth's orbit. The gravitational interaction between the two planets helps shape Mars's long-term orbital stability. Remove Earth, and Mars's orbit could slowly drift. The change would be slow, measured over millions of years, but it could eventually make Mars's orbit slightly more eccentric, meaning it would travel farther from the Sun at one point and closer at another. That alone could drastically affect its climate over geological time. Venus would also feel the change. Venus and Earth sometimes pass relatively close to each other in their orbits, exchanging small gravitational nudges. Without Earth, Venus's orbit would become slightly more stable, but the gravitational dynamics of the inner solar system would still change. But the most interesting consequences might happen in the asteroid belt. Between Mars and Jupiter lies a vast region filled with millions of rocky bodies, the asteroid belt. Many of these asteroids are constantly influenced by gravitational resonances from nearby planets. Earth plays a small but important role in shaping the paths of some of these objects. Without Earth's gravitational influence, some asteroid trajectories could slowly shift. Over millions of years, this could increase the number of asteroids migrating toward the inner solar system. Ironically, removing Earth might make collisions with Mars or Venus slightly more common. But even that isn't the most dramatic change. The real master of the solar system is Jupiter. Jupiter's gravity dominates the architecture of planetary orbits. In many ways, Jupiter acts as the solar system's cosmic shepherd, redirecting comets and stabilizing planetary motion. Earth contributes only a tiny fraction compared to Jupiter, but even small adjustments to the gravitational network can change how Jupiter interacts with other planets over long periods. Computer simulations of planetary systems show something fascinating. Sometimes removing a single planet, even a relatively small one, can destabilize an entire system over billions of years. Planetary orbits begin to drift, resonances shift, and eventually collisions can occur. Planets smashing into other planets, worlds being thrown into interstellar space, entire planetary systems reorganizing themselves. This process is called long-term orbital instability. Our current solar system is very stable, but it wasn't always. Billions of years ago, the outer planets migrated dramatically, reshaping the architecture of the solar system. Scientists call this event the Nice model,
and it may have triggered the Late Heavy Bombardment, a time when massive numbers of asteroids bombarded the inner planets. Removing Earth wouldn't cause chaos immediately, but over hundreds of millions of years, it could slightly increase the probability of orbital instability. In other words, deleting Earth might not destroy the solar system overnight, but it could subtly change the future of the entire planetary system. And yet all of this assumes something important, that Earth simply vanished. But what if Earth didn't just vanish? What if something actually removed it? A force powerful enough to erase a planet instantly would need unimaginable energy. But the universe does contain objects capable of such things. Rogue black holes drifting through interstellar space, cosmic events powerful enough to tear matter apart, or even something stranger, a catastrophic event in the fabric of reality itself. Because according to modern physics, the universe might not be as stable as we think, and under the right conditions, reality itself could suddenly collapse.
At first, the idea of Earth being deleted sounds like pure science fiction. Planets don't simply vanish. They are massive objects made of billions of tons of matter. Destroying one would require unimaginable amounts of energy. But the universe has a long history of doing things that once seemed impossible. Stars explode, galaxies collide, entire solar systems are torn apart by gravity, and sometimes cosmic events occur that are so violent they can completely reshape space itself. So the real question is not whether Earth could disappear. The real question is what could possibly cause it. One possibility would be a direct collision. The solar system is not empty space. It is filled with asteroids, comets, and debris left over from the formation of the planets billions of years ago. Most of these objects are small, but occasionally much larger bodies pass through the inner solar system. Around 66 million years ago, an asteroid about 10 kilometers wide struck Earth and caused the extinction of the dinosaurs. That single impact released more energy than billions of nuclear bombs. But even that event barely scratched the surface of Earth's total mass. To truly destroy Earth, to completely erase it, an object would need to be far larger, something the size of Mars, or even another planet. Planetary collisions have happened before. In fact, scientists believe the Moon itself formed when a Mars-sized world called Theia slammed into the early Earth about 4.5 billion years ago. The impact was so violent that enormous amounts of molten rock were blasted into orbit, eventually forming the Moon. But even that catastrophic collision did not destroy Earth. The planet survived. It melted, reshaped, and slowly cooled again. So if even a planet-sized impact can't delete Earth, what could? The answer may lie in objects far stranger than planets, objects so dense that they warp space itself. Black holes. Black holes are regions of space where gravity becomes so strong that nothing, not even light, can escape. They form when massive stars collapse at the end of their lives. Most black holes remain inside galaxies, orbiting quietly in deep space. But sometimes black holes can be ejected. When two black holes collide, the violent gravitational waves produced during the merger can kick the newly formed black hole out of its original system. These objects become rogue black holes, invisible, silent, drifting through interstellar space. Astronomers estimate that the Milky Way could contain millions of these wandering black holes, and if one of them ever passed through our solar system, the consequences would be catastrophic. A black hole the size of a small city could weigh more than the entire Earth. Its gravity would begin distorting planetary orbits long before it arrived. Comets would be thrown into chaotic paths. Asteroids would be scattered like dust.
And if the black hole passed close enough to Earth, our planet wouldn't explode, it wouldn't shatter into pieces, it would simply be pulled apart. Gravity would stretch the planet like a strand of cosmic spaghetti, a process physicists call spaghettification. Mountains would rise thousands of kilometers into the sky, oceans would tear away from the surface, and the entire planet would be ripped apart into a stream of glowing matter falling into the black hole. From a distance, it might almost look like Earth had simply been erased. But there is something even more terrifying than a black hole, because black holes destroy planets through gravity. What if the laws of physics themselves suddenly changed? What if reality itself became unstable? According to modern physics, this possibility might not be impossible. It's called vacuum decay. And if it ever happened, Earth wouldn't just disappear, the entire universe could vanish with it.
Imagine that somewhere in the darkness between the stars, a black hole is drifting silently through space. No light surrounds it, no flames, no visible warning, just a region of space where gravity is so intense that nothing can escape. Now imagine that this invisible object is moving toward our solar system. At first, no one would notice. Black holes do not glow. They do not emit visible radiation unless they are actively feeding on matter. A rogue black hole traveling through empty space could remain completely invisible to telescopes. But the solar system would eventually begin to feel its presence. The first sign would appear in the outer regions of the system. Comets in the distant Oort cloud, trillions of icy bodies orbiting far beyond Pluto, would begin to change direction. Some would suddenly accelerate inward toward the Sun. Others would be flung outward into interstellar space. Astronomers observing these strange movements might suspect something unusual. But the real disturbance would come later. As the black hole moved closer to the inner solar system, the orbits of the planets would begin to shift. Mercury might move slightly faster around the Sun. Venus could drift subtly inward. Mars might tilt into a slightly different orbit. At first, the changes would be so small that they might only appear in precise computer models. But then, something dramatic would happen. Jupiter, the giant gravitational anchor of the solar system, would begin reacting, because even Jupiter cannot ignore the gravity of a black hole. If the black hole passed close enough to Jupiter's orbit, it could tug the massive planet slightly off its stable path. That tiny change could send ripples across the entire solar system. Asteroids would begin scattering in unpredictable directions. Comets could rain inward toward the Sun. Planetary orbits would slowly distort, and eventually the black hole would reach the inner solar system. Earth would still be orbiting the Sun, unaware that something extraordinary was approaching. From our perspective, the sky would look perfectly normal. The sun would rise, the moon would appear in the night sky, the stars would remain fixed in their familiar patterns. But deep within space, gravity would already be pulling. Long before the black hole reached Earth, its tidal forces would begin stretching the planet. The oceans would start behaving strangely. Tides would grow stronger. Earthquakes could become more frequent as the planet's crust reacted to the changing gravitational forces. Then, the black hole would pass closer, and the real destruction would begin. Gravity near a black hole changes dramatically over small distances. One side of Earth would feel a stronger pull than the other. This difference is called a tidal force. And for a planet, tidal forces can become devastating. Mountains would begin to rise as gravity stretched the crust.
Oceans would surge violently across the surface. The atmosphere itself would start to distort. But the worst part would happen if the black hole came too close. At that point, Earth would begin to stretch. The planet would elongate into a long stream of rock, water, and atmosphere. Cities, continents, and oceans would all be pulled into a narrow ribbon of glowing matter. Astronomers call this process spaghettification. Eventually, the entire planet would be torn apart. Streams of molten rock and gas would spiral toward the black hole, forming a glowing ring of debris. For a brief moment, the destruction of Earth might actually make the black hole visible. The falling material would heat to millions of degrees, producing an intense burst of radiation. Then, the light would fade, and the solar system would return to darkness. The sun would still shine, the other planets would continue their orbits, but Earth would be gone, consumed by one of the most extreme objects in the universe. And yet, even a black hole might not be the most terrifying possibility, because a black hole destroys planets through gravity. But there is a theoretical event that could destroy something far greater, not just a planet, not just a solar system, but the entire universe itself. And it might begin with something smaller than an atom. Physicists call it vacuum decay, and if it ever happened, the universe would disappear faster than the speed of light.
Black holes are terrifying. They can swallow stars, bend space, and rip planets apart. But even black holes obey the laws of physics. Vacuum decay is different. It's not about gravity. It's about the possibility that the entire universe might be unstable. To understand this idea, we have to start with something that sounds strange: the vacuum of space. Most people imagine empty space as truly empty, but according to modern physics, empty space is not empty at all. It is filled with energy. Quantum fields constantly fluctuate, particles appear and disappear, and the entire structure of reality is defined by the energy of these fields. Physicists call this the vacuum state. But there's a disturbing possibility. What if the vacuum we live in is not the lowest possible energy state? What if it's only a temporary configuration, a false vacuum? Think of it like a ball resting in a shallow valley on a mountainside. It may seem stable, but there could be a deeper valley somewhere else. If the ball ever receives enough energy to roll over the edge, it would suddenly fall into the deeper valley, and everything around it would change. Some physicists believe the universe may be in exactly this kind of unstable state. If that's true, then somewhere in the universe, a tiny region of space could suddenly transition into a lower energy vacuum. When that happens, it creates something called a vacuum bubble. Inside this bubble, the laws of physics would be different. Fundamental constants could change. The forces that hold atoms together might behave differently. Matter itself might not even be stable. And the most terrifying part is how that bubble would grow. It would expand outward at nearly the speed of light. Nothing could stop it. Nothing could escape it. As the bubble expands, it would rewrite the laws of physics wherever it passes. Atoms would break apart. Molecules would collapse. Stars, planets, and galaxies would simply dissolve. From our perspective, the process would be instant. We would never see the bubble coming, because the signal of its arrival travels at the same speed as the bubble itself. The moment it reached Earth, everything would be gone. No explosion, no radiation, no destruction in the traditional sense. Reality itself would simply change. The particles that make up atoms might no longer exist in their current form. Electrons might not orbit nuclei. Nuclear forces might weaken. The structures that make matter possible could simply stop working.
And if that happened, Earth wouldn't be destroyed. It would simply stop existing, deleted. But here is the strange part. Physicists do not know whether vacuum decay is actually possible. The equations of quantum field theory allow it, but we do not know if the universe is truly sitting in a false vacuum or a stable one. Experiments at particle accelerators like the Large Hadron Collider have tried to understand the properties of fundamental particles like the Higgs boson, which may hold clues about the stability of the vacuum. Some calculations suggest that the universe might be metastable. That means it could remain stable for billions or trillions of years before suddenly transitioning. Or it might already be perfectly stable. No one knows. And that uncertainty leads to one of the strangest questions in physics. What if the universe we experience is not the fundamental layer of reality? What if it is only a simulation? Because if our universe were a simulation, deleting Earth would be trivial, just a line of code.
So far, we've explored ways Earth could disappear through natural cosmic events. Black holes, planetary collisions, vacuum decay. All of these are terrifying possibilities rooted in real physics. But there is another idea that sounds even stranger, an idea that some physicists and philosophers take seriously. What if the universe itself is not fundamental reality? What if everything we see, stars, galaxies, planets, even ourselves, exists inside a simulation? At first, this idea sounds like science fiction, but the simulation hypothesis has been discussed seriously by scientists, philosophers, and even computer engineers. The argument is surprisingly simple. Human technology is advancing rapidly. Only a few decades ago, computers filled entire rooms. Today, powerful simulations can recreate entire virtual worlds. Video games already simulate physics, weather, ecosystems, and even artificial intelligence. As computing power continues to grow, it becomes increasingly possible that future civilizations could simulate entire planets. Eventually, entire solar systems, perhaps even entire universes. If a civilization becomes advanced enough, it might create detailed simulations of reality itself. And if that is possible, a strange statistical question appears. If simulated universes are easier to create than real ones, then the number of simulated universes could vastly outnumber the original physical universe. Which means, statistically, it might be more likely that we are inside a simulation than in base reality. Some scientists have even pointed out curious hints that might support this possibility. For example, the universe appears to follow mathematical rules with incredible precision. The constants of nature, like the speed of light or the strength of gravity, seem finely tuned to allow complex structures like stars and life to exist. Some people argue that this looks like a system designed with specific parameters. Another strange observation is that space and time appear to have limits. There is a smallest measurable unit of length called the Planck length and the smallest unit of time called the Planck time. Below those scales, the concept of space and time breaks down. Some researchers have compared this to the resolution limits of a digital simulation, just like pixels on a screen. But perhaps the most intriguing question is this. If our universe were a simulation, what would happen if something inside the simulation were deleted? From inside the system, the event might appear mysterious, a planet disappearing, matter suddenly vanishing, reality glitching. But from the outside, it might be nothing more than a simple change in code, a parameter removed, an object erased, a simulation reset. Of course, there is currently no scientific proof that we live in a simulated universe. Most physicists treat the idea as a philosophical possibility rather than a testable theory. Still, it raises an unsettling thought.
If reality itself were simulated, then the disappearance of Earth might not require cosmic disasters or exotic physics. It might simply require someone or something pressing delete. But whether the universe is real or simulated, there is one final possibility we haven't explored, one that is far closer to home, because Earth doesn't need to be deleted from the universe for our world to disappear. All it would take is a change in our own star, and the Sun is far more powerful than most people realize.
In the end, Earth might not need black holes, cosmic glitches, or simulation errors to disappear. The truth is much simpler and much more inevitable. Our planet already has an expiration date, because every planet in the solar system ultimately depends on a single object for survival: the Sun. Right now, the Sun is in the most stable phase of its life. Astronomers call this the main sequence, a period where the Sun steadily converts hydrogen into helium in its core. This process releases enormous amounts of energy, the sunlight that powers Earth's climate, oceans, and life itself. But the Sun will not stay this way forever. Stars evolve, and as the Sun ages, it will slowly grow hotter and brighter. In about 1 billion years, the Sun will become roughly 10% brighter than it is today. That may not sound like much, but for Earth it would be catastrophic. Temperatures would rise dramatically. Oceans would begin to evaporate. Water vapor in the atmosphere would trap even more heat, triggering a runaway greenhouse effect. Over time, Earth's oceans would disappear entirely. The planet would become a dry, scorching world. Life as we know it would vanish long before the Sun itself begins its final transformation. But the real end comes much later. In about 5 billion years, the Sun will run out of hydrogen fuel in its core. When that happens, the balance between gravity and nuclear fusion will collapse. The Sun's core will contract. Its outer layers will expand outward enormously. Our star will transform into a red giant, a star hundreds of times larger than it is today. During this phase, the Sun's outer atmosphere may extend beyond the orbit of Mercury and possibly even Venus. Earth's fate is uncertain. Some models suggest that Earth might spiral inward due to tidal interactions with the expanding Sun. Others suggest it could survive temporarily in a wider orbit. But even in the best scenario, the conditions would be catastrophic. The surface temperature would rise to thousands of degrees. The atmosphere would be stripped away. Oceans, mountains, and continents would melt. Eventually, Earth would become nothing more than a glowing ball of molten rock. And if the Sun expands just a little further, our planet may simply be swallowed, consumed by the outer layers of the dying star that once gave it life. From the perspective of the universe, the disappearance of Earth will not be dramatic. No explosion, no cosmic alarm, just the slow, inevitable evolution of a star. The solar system will continue. The Sun will eventually shed its outer layers, forming a glowing cloud called a planetary nebula. At the center will remain the Sun's final remnant, a dense white dwarf star. And somewhere within that expanding nebula, the ashes of Earth may drift silently through space. But here is the remarkable part. For billions of years before that happens, Earth will remain one of the most extraordinary worlds in the universe, a planet with oceans, atmosphere, life, and intelligent beings capable of looking up at the stars and asking questions like this: could Earth disappear? Could the universe end? Could reality itself change? The truth is that the universe is far stranger and far more mysterious than we once believed. And every time we look deeper into space, we discover that the story of the cosmos is still being written.